Any company update?
We're getting a lot of inquiries. We even got someone who found the dead pre-order link for Tinybox Pros and tried to pre-order two of them. I canceled the pre-orders because there's no way we're getting more 4090s. We have 12 5090s coming. We're working on the Tinybox 2 Green, which is going to be four 5090s in a box. Four 5090s because uh, you can't really power sticks, and they're also super expensive. It's looking like they're going to cost us $2,600. But like, what am I going to say? Like, that just seems to be the price to buy these things in bulk. So I'm not. You guys will see what we charge. It's not. I'm paying more than retail to get a lot of them, which is kind of awful. But I mean, they work it out. They're like, well, okay, they're 2,400 retail. You could hire runners to go around to Best Buys around the country and buy up 5090s, but it's not worth it. They'll just pay us 2,600. So yeah, we're working on getting them. That's the biggest thing. We're also working on a rainbow tiny box just for internal use. Uh,
Mhm.
and we have six reds in stock. So someone buy reds, please. Please buy tiny box reds. We have lots of tiny box reds.
Great. Uh, Next one is also for you. Oh, can you talk about the new LLVM? You have the most experience with that, and also the DSP.
Yes, so we merged OU Vienna Bounty for new LVM. New LVM switches away from LLVM Lite and just talks directly to the library. And yeah, I mean it's a bit more lines, but it's nice to remove the LLVM Lite dependency. Yeah, it uses the ClangJIT CPU program, which is I see a way that we could unify LLVM and Clang into one CPU backend, so they could like share buffers, and they're just like different. Like Clang and LLVM are now a lot more like CUDA and PTX. CUDA and PTX have the same runtime, but different compilers. So we could do the same thing with LLVM and Clang. And then also, this is a way that we can unify uh, like CPU program. I see a way that this can become multi-threaded, which is nice. So yeah, we could build like a GPU-ish runtime environment for multi-threading CPU stuff.
Mhm.
So, but yeah, no, it's basically just LVM light removed and a switch to CPU program instead of the MC JIT, our own form of MC JIT.
Do you want to add new bounties along that direction for LLVM or CPU
Um,
program?
I don't think it would work. This stuff requires a lot of taste to do it right. Uh, I think that yeah, we're not there yet. We're not ready to write this yet. But yeah, no, it's just kind of gonna look like a refactor. I'm not really sure what we could bounty there. Though I am interested. I mean, the thing that I really want to figure out how to bounty, and I think it should be doable, is speed. Like,
Mhm.
if people can get things to be faster, I'm interested in paying out bounties for that. And then figure out how to get things like if you can like add a new trick, that's what I really want. I mean, we're gonna have to deal with. I guess I'll talk about the DSP a little too, and the tricks that are going to be required. So the first thing that I'm working on is a BSP emulator. I have that working. So I'll get that merged tomorrow. We'll have some CI tests for the DSP, which will be nice. And then I can start working on what I don't think LLVM Clang actively uses SIMD. They definitely use SIMD. They definitely LLVM opt will definitely enable SIMD. And CPU performance is certainly a priority, right? Our goal is to be performant on every piece of hardware, and there's only so many tricks. So the DSP basically has three tricks that we're going to figure out how to have to use. One is just SIMD instructions, which is just vectorized math. Another is the DSP has what's called tightly coupled memory. It's like 8 megs of SRAM that you can read and write from very quickly. And then there's also the large registers. So there's registers like memory can be coalesced beyond the compute, and then you can do something like shift the register, which is a very cheap operation. So basically those three things. This is what I'm going to be working on probably for the rest of the month. And hopefully we can finish the DSP bounty, for us, the DSP contract, a month ahead of schedule.
Cool. Sounds good. Anything else you want to add before we move on to the next item?
Maybe okay. So there aren't any SIMD instructions while debugging LLVM and ClangJIT. I mean, I want to. If there's some way I could maybe propose UVM, maybe propose a bounty that will capture what I'm trying to get at with this CPU speed. Like I think if it's a little bit annoying on Mac because Mac Torch CPU uses AMX, but I'd really like to be beating Torch CPU. How about this? We can do it on the CI machines. Beat Torch CPU on the CI machines for like some common models. I don't care if it's LVM or Clang, but we have like a CPU backend, and I want to beat Torch on the CI machines. So yeah, let's see. Let's think about what model we want to do.
Llama.
Llama.
Everyone
Llama's
wants
huge.
llama.
Everyone wants Llama. Yeah, that seems good. Okay, cool. $500
Maybe a
bounty.
yeah.
Yeah, well, what's the smallest Llama now?
I think there's like 1B, the one we use in chat.
Yeah, that sounds.
The small one we use in chat, not the default one.
Is the small one we use in chat a Llama?
Not a llama. It's a K6 quantized llama, right? That one. Anyway, the smallest llama.
Well, let me.
Or
Yeah. Let's.
or
Okay.
GPT-2.
Yeah. No, let's stick with Llama 1B. So Llama 1B faster than Torch on CPU in CI. No wait download needed. Just model speed. Cool. Either LLVM or Clang fine. Great.
Okay, let's move on to scheduler. I saw many discussions. George, you any talk again if this cross-voting is just listening?
Yeah, no, I think I put together some good stuff this morning. Just kind of like Cosmos is doing a lot of refactors that are like getting it to the point where we can actually do this. So this morning I wrote a sched sync. So what schedule is going to become is it's just going to become a becomes map, and then the scheduler will basically assign a kernel to the buffer. And then the tensor will become an assign, buffer, and kernel, and that kernel will point back either to assigns or buffers also. And that'll be scheduled. And then realize is where we'll do like the actual scheduling in terms of linearization. So scheduling means two things. It means grouping and linearization. This will really separate those two things, and scheduling will just be the grouping. There's grouping, and then there's also compilation. So there's grouping, compilation, and linearization. Yeah, I mean, you can see. I think the best way to describe any of this is to just look at that last picture that I posted in Scheduler, which is just like you can see kernels, buffers, and assigns. Yeah,
Mhm.
so my PR is passing tests, but it's not written in a. It's just I just like shoved it after the old scheduler. So yeah, I think
So
Cosmo will.
a sign can point to another assign.
A sign can point to another assign. Yes, you can stack a sign. So the buffer input
Oh,
to
that's
the
the
assigns.
version.
It's versioning. Yes, it's versioning, and I believe that I got the top sort right. So I have a top sort that adds extra edges to enforce the versioning.
Mhm.
Uh, yeah, so I think I'm happy with it. I think the top sort's right, but I think that just it's just the graph construction. So that's what like we were going back and forth about. We have to figure out how to do the graph construction without doing a BFS, but I think that's totally doable. So
Okay. No, that's exciting. Graph construction is a challenge. Great.
yeah, it shouldn't do the BFS. Yeah, it's going to be a challenge to get those things exactly right, but I think at the end you'll be much happier than things like preloads and pre-schedule and stuff. Just
Yeah,
construct the graph.
preload is sketchy and adds other limitation to a site.
Yeah.
So exciting. This is great. It shouldn't do that BFS. Okay. Causally, if you want to add anything, you can just type. Otherwise, I'm going to move on to the next stuff. So MLPerf, ResNet, I have been trying to debug this for a week. So my current conclusion is, I think our ResNet was not less stable even before the new multi and new gradient change. My impression is if we use more tensor cores or we use different, if we use float as the type, then the numeric is much better. And if not, there can be like very small diff. So my conclusion now is because the kernels are grouped slightly differently now, we do tensor cores slightly differently. That's why we see a little bit of numerical loss. It's very possible that we can tune the hyperparameters again, so that it converges again. But I don't feel like that's a top priority now. I match every possible source of bugs like I can think of, and I didn't really find anything. And also prior to the new multi and gradient change, if we disable tensor cores or if we use float or we use Winograd, none of those really converge. So my belief is our hyperparameter was overfit to that setting and it's never less stable. So
Yeah, makes sense.
yeah, so that's a little bit annoying. I'm pretty sure if we like increase the epoch and the warm up, we can probably find another thing that also converges. I just don't think it's worth it, given that we are going to change scheduler again, and overfitting this really doesn't help.
No, I definitely agree that overfitting doesn't help, but we have to find some way to deal with like where is this numerical instability coming from, and how do we debug things like that?
Yeah, so I think we can talk about that in the later tensor core stuff. I think
Well,
this is
is it bad with?
definitely. Oh, sorry. Go ahead.
Is it good with Flow32?
No, but our ResNet was also not good with Flow32.
Oh yeah, no. See, that's much more concerning to me.
Yeah. So that's why I believe it's none of these stuff, and it's just the numerics. Or
Yeah. But if it's numerically unstable, like Float 16 is not numerically stable, but if Float 32 isn't working, we have like
no,
something that's
so
really like a bug.
I think using tensor cores gives better numerics, and there's no Flow32 tensor core. So all those like reduced loops much worse compared to tensor core in terms of numerics. That's my belief.
So on
So
NVIDIA, we can use
so
TF32.
B flow 16 was converging.
I see. Wait, but also
So
why do we have worse numerics if we're not using tensor cores?
I think it's just the this I am not too sure, but my belief is because we do accumulate on ACC, right? And the problem is if that ACC becomes too big or too small into a negatives, then your additional add might be canceled.
How do tensor cores fix this?
Because tensor cores kind of add 8 together and add that to our ACC.
But we can emulate that.
Yes, yes. So that's we also previously know if we apply no opt or like no reshape to that no unrolling, it's much unrolling is much better numerical wise. So I don't have a good framework to describe this, but I think that might be the source of issue here.
I'm very interested in a framework to describe this. If
Okay.
this is a real thing, like I've always wondered like how much better deep learning could be if this stuff worked.
Which stuff?
Just in general, like how many things in Torch are numerically unstable?
It's also
I've
very
had
possible.
problems.
Yeah.
Oh, I mean, this is not a TinyGrad specific problem. I've had tons of problems in other frameworks with this too.
Mm-hmm. Yeah, so something to think about. I don't have a good solution now, and I don't think it's any of those unsync metronome change or gradient change. I think those looks fine. It's just things are looping slightly differently now.
Yeah.
Yeah, so that was the conclusion, and I'm also interested to see like how we quantify or make numerics better. Okay, so bird is the thing I will talk next. We don't have dropout now, and for some reason, it converges better without dropout. I'm not sure why. Maybe we have a bugging dropout or something. But since we don't have dropout, we cannot really talk about performance. And also because we remove multi, I think we move multi and like use more memory, so we can also not fit the current bird fetch size. I think the improvement to bird those kernel groupings thing would live in the new world after we have the new scheduler. So that's why I'm excited about the grouper change.
What do you mean by a new scheduler?
No, the grouping framework.
Well,
Can
yeah,
I
it could
can I
be.
go and do the multi-reduce back to back now, or can I go and do the fuse arrange now, or should I wait?
It is a dream. Yeah. I mean, I want to definitely get this kernel stuff done first because then we can like at least see what's going on. It's becoming more readable. The scheduler is definitely a lot better than it was a few
Mhm.
weeks ago. But yeah, no, maybe it's still hard to do those things. But I don't understand how this affected the memory for multi.
Oh, I thought we have more kernels now.
Oh, this might all be cast before view stuff. Oh,
Uh, Not really. I test after removing cast before view.
huh. And I'm not really sure what else changed. But if you see that thing, like the cast before view thing is really just it all comes down to when you realize expands and when you don't.
Yeah. Yeah, I have a test PR on that, but that saves memory sometime and disable tensor cores in other times because now you merge other things that tensor cores up doesn't allow. That's a bug in the up of tensor core. As it stands, it's not necessarily better.
Wait, well, I don't understand. There's a bug in opt-op of tensor cores?
No, so there are current tensor core above only triggers tensor core if it's from a load or from a cast after load. If you add more stuff before that step, it doesn't trigger tensor core.
Ah.
So tensor core should just be a reduce, right? Not concerning about the ALU before that.
Well, no, it's a Mullen to reduce.
Yeah, the more and reduce.
Yeah. Yeah, I mean the tensor core stuff it has still got a lot of old fashioned code that needs to be rewritten as rewrite rules. I'm not sure who's going to do
Uh, let's see.
that. Yeah.
Okay, so let's ResNet and BERT. I also add ops.pal because we want pal, and I wrote the new gradient for pal, and that's very short, so I'm pretty happy. It currently works on some backends that's easy to implement pal in the renderer. I think for Clan and LLVM, we either need transcendental style stuff, or I think there's a way to call this. So I'll look into
Wait,
that.
we definitely need transcendental style stuff.
Okay,
I mean,
then maybe find a way to write transcendental for Paul.
wait, but can't you just use what used to be in tensor? Used to be in tensor.py?
I don't know if that's correct because previously we had some issues in backward, but maybe for forward and just copy that should be fine.
I think just forward and copy that should totally be fine. And then just, it's like transcendental style. It's just that. Just do a rewrite if the backend doesn't support path.
Okay, that sounds good.
We
And
may also prefer that on GPUs because GPUs don't have POW instructions.
yeah,
Like, yeah, I don't think we actually want to use, like, if the renderer has a POW, I don't think we want to use that. I think you probably always want to do the rewrite.
I mean, this we can benchmark after we have the transcendental, right?
Yeah, sure.
Yeah, only GPU and Metal can call the Paul. I don't know what that calls into.
It's not real. It's not real. It just generates tons of crappy GPU code.
Okay, great. Yeah, so that's Paul. And also after that, I would fix the integer again. I disable old integer. It was not correct anyway, and it was blocking some other stuff. A range like, or similarly once like, or anything that depends on the like that I think it almost feels like you want you up for that, and the source is the thing you want to be like to, then you resolve after that.
No, I don't think you want to do that.
But then how, like, locally,
We
how
just,
do you know what it would look like?
you mean access for multi?
Yes.
We just need to move that logic into ops and have it just recursively compute it.
Also like device.
Yeah,
Is
you
that how?
definitely don't want to, like device. Yeah, you definitely don't want to start adding, like, POW is fine, but adding UOps is bad. Like, we need to
Yeah.
delete a lot of UOps,
Okay.
right?
Oh,
Because
that
you could
sounds great.
imagine a world where someone eventually is like, well, why don't we just have a conv UOP?
Yes. Let's have an A range UI. I want an A range
A
UI.
range UOP, yeah.
Yeah. Okay. Okay. I'll think about that. We can definitely do like a device-like style to propagate the axis in a non-lazy
Yeah,
fashion.
yeah, that's the right way to do it.
Okay. I will think about A range. So another thing is, I think A range specifically for BERT, because we cannot do the compute on device, we need to create one big A range, then copy that to individual device. So that waste memory. But I have a good idea yet. Think about that. Definitely not A range you up.
We're getting closer to being able to write that in the scheduler. To being able to, so we have this thing tensor map. We're getting closer to be able to add rewrite rules there. That will do this stuff nicely.
So the problem is kind of you don't really know A range is that in a much later rewrite rule because the A range rewrite rule is in rewrite. So only after
Wait,
you
oh, but no, that doesn't matter. A range, while it's in the scheduler, is just a reduce on a const. And a reduce on a const should trivially have all devices just shoved through it.
but then how do you know your reduce on a const can be independently compute on each device?
Of course it can. It's a reduce on a const.
Oh, okay. Yeah, you're right.
All right, yeah, no, this is a much simpler rewrite rule than the fancy A range folding stuff.
So I was thinking about you do a reduce on the A range again. Okay. Yeah.
No, yeah, no, not at that level. Just look at this in Viz. I think it might actually be really simple now.
Okay. Oh, sounds good. Okay, I will look into that too.
Yeah, I mean anything. So what I'm imagining it's doing is like creating this. So it's got like a const, reduce, and then it's got some shard, right? And you could totally just shove
Yeah,
that. I mean, you might even be able.
you can shard that on the const and you reshuffle so the reduce after you apply the multi thing to the const.
Yeah, you might even be able to put this in multi.
Yeah, something like that. Something like that. Basically, you realize your const can be split into a multi of sub like multi of const that's smaller, and you have the
Yeah,
shape layer, and you apply the reduce to that.
yeah.
And if it's even better, wait. Okay, you still need to figure out your offset for every device.
I mean, you need to
Because
basically shove the thing. Yeah, you need to reshuffle the views with the other stuff.
no, but for A range, say the first element of your A range on every device depends on which device you are, right? So for the first device, this is 0. For the second one is how many const there were before your device number.
Yeah, but that just expresses itself as a view.
Why is that a view?
It's a view. It's just like a slice, right?
Yeah, but okay, I will think about this more. I think there are some details that I'm not too sure.
Post the pattern in Viz and look at the pattern in Viz and post it, and then we can talk about it.
Yeah, that sounds good. Okay.
I'm curious now what it is.
No, great, exciting stuff. Great. Let's move on to drivers.
Yeah, so I've been working mostly on the PXS and composing stuff. So I'll continue to do this week as well. And to good work and leap USB. So, but it's still mostly sends like SCSI comments. So yeah, I'm just now looking into the firmware to find a better way. Yeah, to access
Yeah,
these A bars. So yeah.
I think the bigger advantage to libUSB, I didn't expect to get any more perf. I just expected it to work on Mac.
Limogen, I think you cannot hear you.
Yeah, I mean, I had some connection problems.
Oh, okay. So I'm not sure if you are talking, but if you have connection problem, you can also just post in the channel.
Yeah. Were there any questions? Maybe I missed them. So.
No, it's just you have like background noise.
Yeah. Okay. Sorry about that.
No worries. But yeah, okay. No, so I see from your post. Yeah, I'm interested to see what's different between the 24 and the 23. I bet they just moved a bunch of commands around. But fundamentally, we're going to have to figure out how to use the fast AMA stuff.
Yeah.
I only hear you say yeah, but okay. Okay. If you have Imogen, if you have anything else to comment, you can just post in the channel. When we are going to move on to Tensor course.
Hi, hello. For
Hello.
search over tensor core shape in each initial benchmarking gives hints that it is slower for smaller beam, as it tends to find local minimum with smaller shapes. Though this might be a problem on the search algorithm rather than on the searching over the shape itself. I think we might want to add this, but under a disabled flag, at least until the search algo gives better results, or like only enable it if the beam count is high enough to overpass this local minimum.
I see. Yeah, I think for your ER, it's probably good enough to include some examples. So my comment was I just want to see there are some examples that really pick these actions to making sure it's correct.
Yeah.
If you think it's better to gate this, depends on bin number or something. I mean, unless it's making things drastically slower, I think it's probably fine to leave it as is. Our search algorithm is not that good with tensor cores anyway. So
Yes,
I think
I
more too much
no,
on that.
Yes, I would flag it under a beam count or a flag directly, because it gives like a smaller worse performance, considerable worst performance for some shapes if like the beam is like 3 or 8 or something like that.
Okay, sure, no problem. So my point was, I want to see some examples that really pick these new tensor cores and making sure it's correct.
Yes.
And
Okay.
otherwise, the default setting, just I will use whatever you recommend. You are more experiencing running that.
Okay. Thank you. I also added accumulation on half for tensor cores for NVIDIA and PTX. Like it's the PR open. I don't add it, and also fix an annoying bug. And for the numerical stability framework, as well as for the 5-gen tensor core, I started studying, so no update from my side. And from what you mentioned in this meeting, I can focus on the rewriting the tensor core's old-fashioned code if you think it's like a priority. Otherwise, I'll continue working on the things I mentioned above.
Well, I'm really interested in the framework of numerical stability. I'm really interested in a way to just start discussing numerical stability and like saying, okay, what's actually going on here?
Okay.
Yeah, I think
Sure.
it's a lot of like a lot of these like enrolling more is it's more precise, or using Tinycorp more is more precise. It's like anecdotal, and it would be nice to have a way to discuss things like this. Maybe there are some terms or papers that's I'm pretty sure people have studied this before, and it would be good to have some terms and ideas to like thinking about a problem.
Yes, yes, I agree. Though it might take an extensive research from my side, so don't expect like rapid progress.
No worries. If you find anything interesting, just post in the channels. I can also take a look.
Sure.
Cool. Thank you. Let's move on to Web GPU and TinyChat in browser. So WP Med said, I think the PR is close. It used some more lines. And last time I read it, I think some of the functions thing can be cleaned up a bit.
Yeah, I still think there's a bunch more cleanups to do on it. I raised the bounty to $400. It's like plus like 100 something lines, and I don't think it has to be.
Mhm. Okay.
Yeah, so I think just that. I gave a list of things on that pull request. But yeah, we'll talk
Okay.
about one.
Oh, great. It's always nice to remove more dependencies.
Yeah, it's good to use Dawn as well. I mean, it's the real one in Chrome. I double checked this. I looked. I'm like, I don't just want to switch to like some other library, but if we're switching to the one that is in like the only web browser anybody uses, sure.
Yeah. Okay. This is good. How about a TinyChat in browser?
Who you should be a speaker if you want to talk about it. Don't have to. Still muted. I think that's on you. I mean, you ever had the speaker role.
Yep, my bad.
No worries.
Yeah, so I don't have that much to say beyond my PR message that I posted on Friday. Concerning that, I'm hopefully within a day or so, I want to get it working on my iPhone 15 because that's the only phone I have to test. And, maybe we could test on some other phones and chat, but just dealing with some bottlenecks on the phone that I wrote about. Concerning the Float 16 support from the other PR, like that's exciting, and we can enable that in TinyChat after it's merged. Might take a little development just to get it in there. Not everyone's going to have that flag enabled in their browser, so we'll have to account for that. But I think we can include that.
Yeah, I'm less worried about making Float 16 work. Is the model being cached? Right now, when I go back to it, it's re-downloading the model.
That's interesting. It should be cached. I can do some testing there. I mean, it is for me. It might depend on your platform. Like different platforms have different policies for IndexedDB caching. May I ask?
The
Is this
stable
on your?
diffusion caches work. This is Chromium on my Mac.
Okay, yeah, I can look into that. I do have a Mac that I could probably use for testing. So
Well, I'll double check too. I just went to it right now and I saw it. It's downloading model. My internet here is kind of slow, so it's moving but slow.
I can also test later.
But cool. Yeah, no, and And you're waiting for iPhone before you want to like start posting this link places and getting feedback and
Yeah, just because like, I only use X on my phone, and I bet a lot of people do too. So, if someone sees a tweet and they click on it, I want it to, yeah, it'd be great if it just worked on a phone. Unfortunately, like I found that there's some really tough constraints for playing on the phone. So I'm thinking like, if someone clicks on it on their phone, I'll just have, and if they don't have WebGPU enabled, I'll just have like a link they can click to like tell them how to enable WebGPU and then reload the page, and then it'll work. Because Clang won't work on phones, I'm pretty sure.
why not?
Okay, so yeah, I posted on
I
this.
saw
I mean,
I saw the stuff about the
I think we can make it work. It's just like right now, it's just I can't allocate 1 gigabyte byte array, a JavaScript heap array um, in on my browser based on my tests. And we could. That's the main bottleneck, is just the token embeddings when they're not quantized, and when they're in float 32, it's 1 gigabyte. If we shrink it down, um, we can get it down. We can quantize it to something, and it'll work. We'd have to modify the Llama inference code because that's not implemented in there yet. But I'm sure we could do it. I don't know what the speed cost would be, but
Wait,
yeah,
the
it's all
token
doable.
embedding alone is that large?
Yeah, yeah. The token embedding in float 32 is 1 gigabyte.
Whoa. Okay, I didn't realize that. Yeah, I thought this was just for like the whole trying to load the whole thing into one thing. And I'm like, can't you break it up by tensor? But
Yeah, unfortunately, that one
interesting.
tensor is, yeah.
Uh yeah, we'd have to kind of does the I mean this is kind of on the Tinygraph side, but does quantization work?
I mean, I've quantized everything else. Well, not everything, but like the stuff, all the linears, in the transformer blocks. Um, because that was already just supported out of the box in master branch code. Um, like I haven't. I mean, to be clear, I think Chin, you mentioned before, I'm using Q6K quantized weights and then unpacking them,
Yeah.
for the token embeddings. So, like they can be quantized. It's just a matter of like actually implementing it. Like if we were to, for instance, instead have that just be a quantized, uh, I'm sure we can make it work. It's just, I just don't know if there's going to be like a big speed cost. I mean, it's probably fine. It'll just take some development time.
Yeah, I think this is outside the scope of the bounty. I'm happy if you get it running on a phone in any way, shape, or form. I'm happy with that. But
Yeah.
just something for the future.
Yeah, one last comment on that. Yeah, so that's what I'll do, like just targeting web GPU. Like the main reason I don't want to really do that right now is it's not so much because I don't think it can be done. It's just more the Clang speed isn't that fast. So like if someone uses it, I want them to, not have a bad opinion
Yeah,
about the speed.
yeah, that's reasonable. We added a $500 bounty for speed. Someone can get CI llama to be fast. But cool. Yeah, let's focus on web GPU then.
Thanks.
Great. Okay, let's move on to other bounties. Onyx, comment on the PR to merge Onyx files, I think it's fine. But please do that in separate PRs, just one for simple copy and the subsequent ones for real change. That's a lot easy to review. RetinaNet.
Hey guys. So for RetinaNet, I'm getting been bugged with the with this issue related to the data loader test that I've written for it. Because it's kind of flaky sometimes when I let's say merge into master and all that. I try to narrow it down further to see what the issue is. But right now it seems to be stable, but I think it's with the parallel testing on PyTest on CI is probably causing the issue. But I'll take a look into it a little bit later, just because I want to get into the training phase. And for the validation one, I reran the validation data loader because I recently implemented that. And made sure that it matches the metric, just using the pre-trained model, so that it works. So and it did verify that it works. So I'm actually just going to start the full training hopefully this week.
Great. Oh, and I just remember I forget to reply to your message. Next time, just post in the channel. I
Okay,
don't
sounds
read.
good.
I don't read person like DM that much, or I read it and I forget to reply. Yeah, and I think we discussed in the PR about using multi GPU for eval, and apparently the bottleneck is not on that. So I think it's much better to figure out what it is before scaling to multiple GPU.
Oh yes, that's right. Thanks for that comment. Yes, I'll take a look into that as well actually before I do the full training, so that we don't waste time, evaluating as if it was just one batch size, because it's similar speed anyway for some reason.
That's good. Okay. Graph rewrite 2.0. We don't get Thompson here. I don't see any real progress there.
Yeah, I haven't seen progress there. I almost feel like graph rewrite's going to be one of these things that if no one does it by March, I'll start taking it seriously.
Okay.
Because I mean, it'll just speed the whole thing up. It's how we're going to get Python speed. I don't know. My dream is like I want to turn the renderer and the compiler into graph rewrites also. And then graph rewrite 2.0 can support things like multi-core graph rewrite.
Mm-hmm. Yeah, because every rewrite is kind of local. It's local, so you can definitely parallelize a lot of those.
Oh yeah, you could totally, for all the functions, you can parallelize them, and you can also do speculative rewriting. You can.
Not sure how does that work. You have a sequential nature.
Yeah, well, so it's not that sequential. So there's a bunch of ways you can parallelize, right? Now we're just kind of make like a big queue for them, but you could parallelize for free, just where you do the matches, right? Like call all 5 match things at once. This is the beauty of UOPS being immutable. Okay, fine. It turns out that only 2 of them return. Just the first one was needed, right? So it's speculative.
Mm-hmm. Okay, that sounds good. February already.
Well, my February is going to be all DSP and scheduler.
Yeah. Okay, I would comment on the sorting add chain stuff. So I discussed with, I think the authors here. So I discussed the author on the PR. Basically, my main concern is if we're going to add more stuff into this, the order of ops, or basically when we tupleize an UOP, how do we compare the order of lows? I want a better way to manage this, because the worst case is we made a bunch of higher level tests, and maybe it's very difficult for this to pass if we ever want to refactor some part of the UOP, and that's why I propose having a lower level, older test on stuff. But the author said he's thinking something else, and he's writing a report on that. So I'm waiting on that. basically, I want to avoid the case that it might works now, but down the line it would make future changes much more difficult because you need like 10 pieces to click to pass a test. But otherwise, exciting about this stuff, I imagine it will also improve the kernel speed.
I've always imagined these tests looking kind of like U-paths. They look like graph matchers that determine if the test passes
Mhm.
instead of the strings.
Yeah, maybe that's fine. But then, isn't that like copy your implementation to your test? Like, what's stopping you from just copy the same U-path in the implementation?
Yeah, I don't know. Or maybe the other way to test this is to actually just like evaluate these in Python on random values and see if the values are the same between like the simplified and the unsimplified. Do like a Monte Carlo test.
Yeah, but then you are not really testing the behavior, which is some specified order of doing ALUs. I don't know.
Yeah. I don't
Uh,
know.
I,
Some
I think
combination of these things.
yeah, I think now is probably fine. We just do one off and think about a better way to do that. Yep, not the biggest problem. Getting things done is more important than figuring out the perfect way to write tests.
Oh.
Okay. Yeah, that's everything on the agenda. Do you have any questions, comments?
I have a few closing notes, and if anyone has questions, we have a little extra time today. I was just thinking, I was talking at dinner about how long it really takes before projects like this become really successful. You can think about Linux started in the early 90s, and it took like 10, 15 years. And then you think of how long Git took. Like Git was this early thing that was hosted the Linux kernel, and now it's multi-billion-dollar business. LLVM and Clang. I remember. I mean, I was there for Clang. I was there for everyone used GCC when I was in high school, and then somehow in the 20 years that came after, everything switched to LLVM and Clang. That's how long it takes to really build these fundamental projects. But I see Tinygrad being a project that lasts 20 years, and being a major piece of infrastructure for all the software 2.0 stuff on both like operating system looking side and the compiler looking side, because we're in this beautiful paradigm where compute is so much simpler to talk about. Like even when you get to these complex things like mixture of experts, it's like not really complex. Like the way that memory depends on values is so restrictive compared to programs, compared to like a web browser. So yeah, exciting times ahead, and it'll be beautiful infrastructure for the future. But everything uses Clang, right? Like HIP is Clang. Sure, some things in Linux might still use GCC, but HIP is
Yeah,
Clang.
and I think a lot of these softwares really has a selling point, even when they are not that mature, and it's very clear from the start what Clam is trying to do or what Git is trying to do, and they do the things pretty well, and they later broadcast into a much broader scope. I think Tinygrad is similar to that. Initially, it's for like running inference on device for comma, then running inference on all kinds of hardware and make it fast, then move into like training and distributed stuff.
We still have further to go with inference. If we get comma on the DSP, that'll be great too. Could happen first half of this year. I should say more LLVM than Clang. I mean, everything is LLVM based, right? Like the Qualcomm shader compiler is LLVM based. Metal is LLVM, it's Apple, but
Cool.
cool. Thanks, everyone.
Cool. Thank you. See you next week. Bye bye.